Jerome JT62 back here with another one. This one is something I'm really excited to show you guys. It's my hot wire foam cutter. I'm going to dive into this and show you what it's all about. If it's something you're interested in, it's coming right up. Here we are, we're back. I'm going to power this up here. You can see the display. It has lighting for the table. Also, it has wired in an auxiliary for accessories, handheld, bows, what have you, and a pedal switch. This design was highly looked at from Jeff on stuff I made in the UK. I saw his design on this, and I really liked it. So many of the features here are based on his idea. Some of them I changed, such as how I mounted my sides, the rails I used, my tensioner, and things of that nature, but the whole idea and concept was based on his design. So we'll look at this a little at a time. We'll try to keep this short and simple. We'll start at the front face here, I suppose, and then we'll work our way up. I'm going to have to move this up a little bit too high so you can really see stuff, but we'll get around it. So, the first thing we're going to go over is the layout of this. It's just sheet aluminum across the front of it. I kind of like that, painted black. I chose to use this switch for my LEDs. I want the power switch on and off, and I want to be able to turn the lights off. It will. This is your heat adjust and control through the PWM controller and your display here. This auxiliary switch basically ties this switch end down here for handheld. Future devices that'll be made. I used aviation plugs. These are 2-pin up front, but they're all over eBay. And also a pedal switch. I can't see a reason to keep this on when you're not using it. Not only does it burn or melts the material you're using, but I want to have some control on and off with that. There's many 3D printed parts on here, from the caps on the rails, the knobs, the bearing holders on the back, which we'll take a look at, and the IEC connector for plugging this in. So let's look at the top of this and how you tension it up. So this is a pretty simple design that I came up with. This is just your standard banana plug connector. We'll see if we can focus this in here. There's a hole drilled at an angle so you can just slide the wire, and this is pinched in here with a washer. And then the spring, I used 2 of these grounding clips, 2 nuts, and that's how the spring is connected. This is just formed around this brass tube. It slides up and down if you need to move it, and moves from side to side. And there's washers on top of the tension. And I used toilet flange bolts. They actually slide right in here. You'll have to take a little bit off the sides to get it to slide in, but they're perfect. They don't move around, so all you have to do is basically take this and pull it spring tension all the way back. I can't one hand that, and then just tighten that up so it's a quick release. And basically you pull it back to this cover, this channel cover. I use channel cover rather than drilling holes in here. So I think you kind of get the idea. The ground, or the actual positive load side of this, is connected to this plate. It's not a clip on here, so it gets its power when it touches the standoff here, which is like Jeff's. That has, you know, the holes are pretty good size, so you can have adjustability to move it around. It has adjustable excuse me, side to side movement like this. When you look at the back, you'll see exactly how I designed that on the back. This is actually on bearings itself for rotation purposes. The fence is the same thing, same concept as up here with the pinch method and flange bolts, and you just slide this forward, and that's with L brackets. There's an interest in this. I do have the build videos from this, and I'll post those, but if not, we'll just leave it like this. So I'm going to remove this wire here, and I'm going to spin this around to show you how to remove the bolt. So the first thing is just to loosen that back nut up. Doesn't take very much force. You don't have to use wrenches or anything on here, so it's a pretty quick release. And then just pull the wire out like that, and that releases. I wanted the bow on the back to be removable. I don't want to have to store this with this long section to the sides or the back. So if you look here, this has bearing blocks here, which are 3D printed, and there's another knob in there. So basically all you do is loosen this front section right here. Another quick disconnect for the positive and the lighting. Just take that off, pull it off, and this whole thing slides off. Not only that, but you can adjust this, and if you needed to, and you needed an additional 3 inches, this is made so you can slide this bow up and make it even longer and give more space than what's actually in here. It's about 14 inches right now, 14, 15 inches. So you could theoretically move that up to about 17 if you needed something that high. So I'm going to loosen these up and slide that out. See if I can one hand that. Just take that out like that. We'll remove the bottom one so I can one hand this. Simple. And you'll notice I kept the back open and then just covered the ends of this with aluminum flat bar, because I need to get underneath there to adjust this. Not only that, but I want the airflow in there, and that is the IEC connector with a fuse. So there's an on and off switch back there lit, and you get a look at the fence right here. So I got to kind of move myself in here. I don't want this to slam down and slide like that. So anyway, you just loosen that up, and that bow comes right off there for storage. And you can get something like Velcro straps and just strap that in here, but now you see the low profile that you have. And then this is your angle adjustment in here. So we'll flip it upside down, and we'll take a look at the bottom. Now before we do that, let's look at the bow here. These are LED strips that you can cut to length from super bright LEDs. the wiring just goes around to the side, and then it's covered with L channel covering, which is right through here. You can see the wire, and it just comes down just like that. You get what I'm talking about. These are pre-made items. I bought those. I wasn't looking at making it. So these are 5mm bolts, 8mm in length. So you have to get the T-nuts for that. You get drop-in, roll-in, whatever type. I have them all, so these are drop-in. But that's the bow. Here's a shot of the bottom and the wiring. Mains comes through here, again through the IEC. It's connected to the power supply. One has to come up, obviously, to the switch. Then you'll see two wires coming off of here. One of them is the neutral to light the switch, and the other two are the switch side. That's the PWM controller, which comes back to the 12 volts. I chose not to use batteries. I want this switched. So this is jumpered across and switched with the main power supply. So this comes on, and that lights the display, and also I needed it for the 12 volts for the LEDs. I don't want to run them off this power supply. I don't know if this senses the whole load or just what's running through this shunt. I think it's just what's going through there, but I separated these. That's what it said to do, so that's what I did. And then I use a terminal block to basically jumper all my positives and negatives together. This is the bottom. This is the tensioner. It's a pretty simple design I made with L bracket. Just cut it down. This washer has a hole in it, and that's so you can slide the wire so it won't skew it off to the left or to the right, and it'll be in the center when you tighten this up. So basically all you do is just pull the wire through, put a couple twists in it, and then when you put tension on it, it'll center this up, and then you tighten this so it's in the center of the heat sink, which is 1/2 inch thick, little, well, 5/8 thick, and 1.5 inches in diameter. And then your negative just comes through here and runs to the shunt. I'm not going to go through all the wiring on this, but be aware there's two types of displays. There's the 3-wire and the 5-wire. You want the 5-wire, do not get the 3. I spent a lot of money on things I think that I didn't need, so be careful with that. You need the 5-wire with the shunt, because if you get the 3-wire, you need a minimum of 4 volts to power the display, or it won't read anything. But I want the display on even with 0 volts, and in order to do that, you need power going to it. And the only way to get that is through this shunt. So it'll read 0 through 30 volts now, or 0 to 100, I think, something like that. So these are about $10. That's the adjust for the PWM. All the negatives are tied together, and they go into one spot each. So all of them come through here, come back to the shunt. Then this negative is tied to the accessory, and the other negative is right here, that are tied to this. And that's the easiest way to do it. Just do that. And in order to switch the power from accessory to auxiliary, because when I hit this switch, if I go to accessory, it disconnects this power to this wire, the positive side, and sends it to this. So you'll need a double pole single throw. I had ran into some problems with this double pole double throw. I burned some stuff up, which wasn't good, which is my power supply. So I went down a long road on that one. I figured out that I can't use a double pole double throw and put negatives there and positives over there, because it crossed over and didn't do any justice. So careful with that. Again, if I post the build video on this, then I'll go more in depth into this. I just wanted to show you my idea on this and how I built it. You look at the sides here. There again, this is 1 1/2, I believe, L channel. And the top sits right on top of this. So it's perfect. The rails on here are 2040s. That's what I had, and they're very rigid. Not only that, but based on the design and using this L channel, there would have been a gap here. So these worked out perfect. Pine, just stained and screw down here with number 8s. Now the L channel here, and the reason why the 2040 works out is because it has 2 slots. So you have one free up at the top here, and you use this one here on the bottom slot, and that's how you mount that to this top. And then this just sits on top of that, and it makes a clean, flat surface along the sides. I hope you get what I'm talking about there. We'll flip this back up, show you how to connect the foot pedal, go from there. Be right back. So there's a foot pedal all over eBay. They're $7. This came from Temco, like this wire. Incidentally, this is 28 gauge nichrome. It's 500 feet. It's like $16. That should last me forever. The wire on here was like 1.5 feet. Totally worthless. Lucky I had some SOO cords, and I put 10 feet on this. And the reason why I did that is since this is going to be a standalone base power supply plus the bow on this side, if I have an accessory and I'm away from this base, I need to be able to move this pedal once I make my heat adjustment. So whether I'm using a handheld knife or what have you, then all I need with me is this pedal. This will not work without this pedal. The load or the positive goes through here, so all you do is just plug that in, obviously. And this is going to have the same thing. It's going to have a long cord for the accessory. It's going to plug into the base of whatever I'm using. So there'll be the male and the female side on each one of these. So again, I can't see the reason to keep this on, so I suppose I could put a switch on so it's always on, but I don't see a reason to do that. So at this point, I'm going to leave it like it is. If I need to add something, then I'll do that. Again, these labels, P-Touch. It's the same one I use for my CNC controller. If you looked at that video, you probably have, maybe you haven't. But anyway, you can print custom labels up. It's not just your typical label maker. You use your computer to print them. You can make real specialized stuff with it, but I kept it simple. So it's labeled LED, power, heat adjust, accessory, aux, means on. When it's on, this pedal's turned, not the pedal, but the wire up here turns off, and it energizes your accessory through the pedal still. I'll go ahead and power this back on. I put it back together. Takes a few minutes, if that. And we'll go ahead and hit the foot pedal. You can see the 0. And as I come up here, you can see the voltage come up. I don't know if you can catch it, but you can see the wire starting to smoke. And that's 6.2 at 1 amp. 1.1 amp. I actually went and bought a 24 volt power supply, 10 amps. I don't know if I need that. I was thinking that maybe it wasn't enough, but I was cutting this is pretty dense foam. It's like the stuff you use in toolboxes for shadowing tools and things like that. This cuts right through that. Not super fast, but I thought I might need a little more power, maybe up to 15 volts. But at 12, around 12 and a half, it cuts pretty clean. And I think it's as fast as you probably need to go because it doesn't melt your sides. Obviously, you have to keep moving with these. You don't want to sit in one spot because then it'll melt the side down. So once you start cutting with this and moving, you got to keep going until you're done. And that's another good thing about the foot pedal. So you don't have to, you could one-hand it and then come back over here and turn the switch off. You can release the pedal and stop the heat like instantly. Incidentally, these rails are 500 millimeters. So the length on this is around 19 and a half, 19 3/4, somewhere around there, inches square. The 2040 on the back is also 500 millimeters. This one up top is 300, and I had to cut that much off. It's not quite an inch, probably about 7/8 of an inch. I had to do that because I want the distance. I wanted the distance from the front face of this to the back of that, 7 inches, and I want 12 back this way. So if I need to build an extension or something of this and I needed something longer, then I could just pull these caps off and slide it up. I had more 2040. I would just cut those down, maybe cut one of them in half, or maybe not even need anything that long. But just make it so it'll just slide in here and butt up against this. This flies through styrofoam at about 10 volts, so that's another reason why I'm thinking I don't need that 24, but we'll see. We'll see. Maybe, maybe not. Maybe I was being a little impatient. You need to go slow or just as fast as you need to go so you're not burning things. Styrofoam, if you sit and wait, it will melt the sides down and give you a dirty cut. If you keep moving, even with this at like 10.1 volts, around 1.5 amps, you can fly through it. So that's the bow cutter. That is the hot wire foam cutter. Do closing comments and call this one done. I'll be right back. So, in closing, you may be asking yourself a few questions, or you want to ask me. At least Number one is probably, how much did this cost? How much does that cost to build? More than it would be to buy one. We'll put it that way. If you bought everything and did everything right the first time, I had some snafus. I bought some things I didn't need, such as a bunch of these 2020 rails. But after some thought, I went with the 2040s, which is the best thing I ever did. The only one that's a 2020 is this single up here. I would venture to say you could probably get away with, we'll say, a conservative $150, $160. Maybe a little more, depends on where you order and stuff from. Actually, most of the components in here are pretty cheap, but you don't want to burn anything up. So you have to watch your wiring. Make sure you get everything right the first time. And since I'm the guinea pig, you wouldn't order a whole bunch of excess parts. Aluminum, you're going to have to be able to get a hold of. This is about, let's give it maybe 3/16 on the back sheet. You're probably not going to find it like a Home Depot. Maybe a scrap yard or something near you, but everything else except for, again, this heat sink in here. Excellent idea by Jeff, once again. And again, I got to say, there's going to be a link to his channel. You need to check it out. He has a lot of good stuff. A lot of good stuff. And quality things that he comes up with, and ideas such as this. So the second thing you may ask yourself, is this over-engineered? Well, that depends. That depends on what you're looking for. If you're looking for straight cuts, then no. But, you know, again, it depends on how much you want to spend. You can buy these probably for 30, 40 bucks, all the way up to, I've seen them for 1,500. They're a little bigger than this one, though. So it all depends on what it's worth to you. Would I build it again? Absolutely. I'd build another one. I'd build another one in a second. It was a fun project. I enjoyed doing this whole thing. There were some frustrations in there, especially with my wiring. I wasn't quite getting it, but I got that down. But that was at a cost of a couple of burned power supplies. I thought I had a display go out, but I didn't. So now I got 2 extra displays. I always order extra of everything, because you never know these days when they're going to stop making something and you're not going to be able to get it anymore. This 3D printed face here was because initially I installed the 3-wire display. The hole is way bigger. Display's bigger, and that didn't work out, so I had to design up this face to accept the smaller display, which is not a big deal. You know, I was going to paint it. I had one painted, and then I'm like, you know what? I'm not going to bother with it. Why? Looks pretty good just like that. So this whole thing's not all flat. What I wish I had done was put a clear coat on this, because this is a textured finish, and if you have dry hands like me, it seems that you get white spots in here. So my hands are a little dry. Maybe I need to do something about that. But all fun and done. I really enjoyed this project. I know that I'm gonna use this thing. I didn't just build it just to look at. Every project that I post on my channel, I build for a reason, because I use them. We got a few other things coming up that I'm working on. And I'll post those videos. We'll get to them as I start building. But we're going to close this out. I hope that somebody got something out of this. It'll give you some ideas. As Jeff said, there's no plans for this. I'm not going to make any plans. This will give you a base idea of how you might want to design your machine. I designed mine off of his base. You can design yours off of mine, or you can make it like this. But it's going to take you some time. If you're looking to make this on a weekend, it's probably not going to happen. Depends on how good you are. I couldn't make it happen, not in a weekend. But then again, I was still going through how I was going to design things. Originally, I was going to put a flat plate in here, a square. And then there's a scrap yard around me, and they had this thick length of aluminum bar. So it was like a 1.5 foot of it. It was like $12, so I jumped on that. I think they had some more, but I only needed one. So we'll close this video out. As always, hit that like button, subscribe. If you have any questions, leave them, and I will get back to you. We'll catch you on the next one. Thanks for watching.